You are going to be watching a screencast on isotopes, and prior to watching this screencast, you should have already seen the periodic table and the one on atomic structure. You may have also completed the POGIL activities on the periodic table, isotopes, and average atomic mass. So isotopes, as you have seen on the periodic table, every element is designated a square. And in this square, you are given the atomic number, you're given the element symbol, you're given the name, and the atomic weight. This is what we're going to focus on. The atomic weight is the average of all isotopes for that particular element. So isotopes. What is an isotope? An isotope is an atom with the same number of protons but different number of neutrons. So if we are changing the number of neutrons, that means that the mass will also change, because the atomic mass is the number of protons plus the number of neutrons. And you're going to want to reference your POGIL activities that you should have completed, the isotopes and the average atomic mass. So just some examples of isotopes. We have the isotopes of carbon. And before you move on, let's look at the structure. So in the middle we have a nucleus, and inside the nucleus we have neutrons and protons. And the neutrons are exhibited by the red circles here, and the protons represented by the blue. So if we're looking at carbon, we have carbon 12, and the number that follows the name is the mass number. This is a stable atom. It has 6 protons and 6 neutrons. Leading us to carbon 13, again, the name followed by the mass number. Also considered to be stable. It has 6 protons and 7 neutrons. So what you will see here is the number of protons is the same. However, the number of neutrons is different. Leading us to carbon 14, which is considered to be a radioactive isotope, and we'll get into the difference between stable and radioactive later on in the screencast. But what you'll notice is they also have the same number of protons, but different number of neutrons. So because the protons and the neutrons are, the protons are the same and the neutrons are different, that's why we have different mass numbers, because the number of neutrons has changed. So when we're filling out a chart, say I want you to tell me how many protons, electrons, neutrons, what's the mass of the isotopes that I'm given to you. I'm going to show you an example again using carbon. We have carbon 12, carbon 13, carbon 14, just like in the previous slide. And you need to fill in the number of protons, let's say. Well, the number of protons, as you have learned, equals the number, atomic number found on the periodic table. So you're just looking at the periodic table, get the atomic number, and what you'll see is atomic number of carbon is 6. And then for the number of electrons, it will equal the number of protons since it's a neutral atom. There's no charge, so those will also be 6. Now to figure out the number of neutrons, you're going to take the mass number minus the number of protons. So in this case, we have 12 minus 6 giving us 6 neutrons. We have 13 minus 6 giving us 7. And then 14 minus 6 giving us 8. So again, they are isotopes because they have the same number of protons but different number of neutrons. Hence, their mass numbers will be different. Leading us to the types of isotopes. Like I said, we have stable isotopes and we have radioactive isotopes. Stable isotopes are more common. What makes them stable is there is a balance between the number of protons and the number of neutrons found in the nucleus. Radioactive isotopes are a little less common. The majority of them are found from atomic number 83 and above. They are considered not stable, meaning bits of the nucleus come flying out. We'll elaborate more on that later on. And they undergo radioactive decay. So they emit radioactive particles, and basically there's an unbalance between the number of protons and the number of neutrons found in the nucleus. So that's going to end our screencast on isotopes. It's just a brief overview because you've already and should have done the POGIL activities on isotopes and average atomic mass. And later on in the next screencast, you're going to be watching more about radioactive isotopes. We're going to go into that a little bit more in depth. If you have any questions, please bring them to your teacher's attention. If not, this ends the screencast for isotopes.